presentation. This time it is faults and fault detection in district heating substations. And to speak about this, we have Sara Månsson, who is a PhD student at Lund University. Welcome. And I also spoke a little bit to Sara in the break, and it turns out that Sara is a professional basketball judge on her spare time.
That is true. Thank you very much for the introduction. As mentioned, I'm going to talk about faults and fault detection in district heating substations, or rather maybe the customer installations. Just a brief overview about me. I studied in Lund. I did a Master of Science in Engineering Physics, and I wrote a master thesis about this subject, about automatic identification of poorly performing substations and meter devices. And this was the foundation for my PhD project, in which I work with faults in customer installations and also the fault handling processes in customer installations. And my PhD is done in collaboration with Vito in Belgium, and Vito is a research institute involved in a lot of different projects internationally as well. First of all, I just want to introduce a bit of some words about the customer installations. You could say that the customer installations consists of two parts. That is the internal heating system and the substation. Internal heating system, of course, it delivers heat to each individual room and also prepares the domestic hot water if needed. And the substation is the component which transfers heat from the district heating system to the internal heating system. In the substation, there is also a heat meter, and of course we want to make use of the values that we get from there, which is the substation. In the substation, the mass flow rate, the supply, and the return temperatures are measured. And then also the heat is calculated. The heat consumed is calculated based on the measured values. And of course, all of these values are collected for billing purposes and may be used in different ways, not only for billing purposes, but maybe also for data analysis. But as we mentioned before, as both David and Sven Vanna mentioned earlier, it's very important to make sure that the customer installations are working well. And both faults in the customer substation and faults in the internal heating systems leads to higher return temperatures. And therefore, in the low temperature systems, we need to have well-performing customer installations. So the problem today is that many of the utilities have no systematic way of finding the poorly performing installations, that is, the installations containing faults. Many utilities do a lot of manual work with this, analyze data in manual ways. But in the future, we believe that it will be very important to have automatic fault detection tools. And one way of doing this is to, of course, to make use of the customer data that we already have at hand. And when looking at these fault handling processes, you can think of this as a process in 3 different steps. The first one being fault detection, and this is where you detect the poorly performing customer installations. The second one is fault diagnosis, and this is where you actually identify what is wrong in a substation or an installation. And then we have fault correction. And here you can define appropriate corrective measures, and if possible, you can also implement these measures automatically. This could, for example, be some sort of algorithm or something similar. In my project, we focus on the first two, fault detection and fault diagnosis, so this is what I will talk a bit more about today. When looking into this, we think it's very important to look at both the current solutions, what is currently being done in the field, but also to discuss the future solutions, a lot of digitalization, data analysis, and so on. So I will present a bit about current fault handling processes, how the utilities are working today, and also about the most common faults today, because we believe it's very important to know what we should be able to identify when going out and looking at this. And then, of course, also a bit about future solutions and how we are working with this within my project. But let's start with some current solutions. To investigate this, we went out and talked to utilities. We talked to utilities in Sweden, and we conducted an interview study. And we wanted to find out how are the utilities actually working with this today. A lot of this was about customer relationship. We talked to utilities that already had very low return temperatures, and they stated that the customer relationship was definitely the most important thing in this work. They said that it was very important to give the customers a lot of information about why it is important to have low return temperatures, and also what they can do to actually decrease the temperature levels from their substations and installations. It was also important to create clear incentives to why they should eliminate the faults. As mentioned in the previous presentation, this could be done by, for example, introducing a flow component in the price model, but this had to be combined with a lot of information. If you just introduced the flow component, the customer would not understand why they have to pay for the price, and of course they don't want to pay for something they don't understand. So we need to provide them with the correct information as well. They also used some sort of data analysis. Many of the utilities were working with simpler analysis methods involving a lot of manual stages still. And they mainly used this for fault detection, but they didn't really focus on fault diagnosis in this step. So this was something they were really missing. And most of the faults were actually identified when visiting these installations. And many of them, of course, performed regular visits at the customer installations. They had some sort of service agreements maybe, or maybe they even did free of charge inspections, since this was such an important issue to them, to work a lot with the customer installations. And they stated that, okay, of course, this made them have physical access to the substation, but not the internal heating system. So if there are faults located in the internal heating system, they might not be able to identify them, which is, of course, a problem, because you want to find all faults. And speaking of faults, as I mentioned, we also looked at the most common faults in the installations today, and here we conducted a survey study instead because we wanted to have a lot of input from different utilities. And we got answers from 56 Swedish utilities. And in the survey, we included 5 different fault categories, and these are the ones here. The heat exchangers, control system and controller, control valves, actuators, and internal heating systems. And we asked the utilities a lot of questions about this, of course. But one of the main questions we wanted to find out was in which fault category are faults occurring most frequently. And when analyzing the results, we found out that 2 other categories emerged, and those were leakages and inferior gaskets. And the fault distribution that we got was this. So the green category here corresponds to leakages. So that was actually the biggest fault category according to the to the utilities. Then you can see that we have faults in the customer's internal heating system, which was also a very big category here. And then we had the control valve, actuators, control system and controller, and also the inferior gaskets. And then the heat exchangers constituted the smallest fault category. This was a bit surprising to us because a lot of literature speaks about fouling of heat exchangers as a very common fault. But since this study was conducted in a Swedish context, where we actually do a lot to reduce the amount of fouling, we believe that this is the reason why the fault category was so small. But as I mentioned before, the utilities don't really gain access to the internal heating systems. And as you can see, there are many faults occurring in these systems. And therefore, it might be very important to develop some sort of analysis tools that can actually identify these faults in the future systems. Okay, let's continue on to the future solutions then. Within my project, if we look at the fault detection step, we are currently working with the data that is gathered for billing purposes. That is those 4 values, because we want to see how far can we actually get by only using these values before adding extra measurement points. And so the aim here is to be able to detect installations containing faults using the customer data. And we have been focusing on trying to use what we call is familiar patterns. That is patterns that are already known to the industry and makes it easier for the industry to understand what we are currently working with. Of course, we also want to eliminate as many manual stages as possible because, of course, there are a lot of customer installations in a district heating system. And it might be hard to do a lot of manual analysis on this. And also, we want to test how programming may be used to find new patterns. And if we find new patterns, how can we then use these patterns for fault detection as well? If we continue to fault diagnosis, which we also have been working a bit with and will continue working with now, we think that this is a very important step to be able to identify all of the faults in the district heating systems. As I mentioned before, some of the faults might not be possible to see when just visiting the customer installations, for example, the ones in the internal heating systems. We also need to identify some sort of typical fault patterns to be able to see what faults are there, if we want to use the data, that is. And the challenge here has really been to just obtain the data sets where specific faults are present at a specific time. And this is an issue because many of the utilities are not really recording what is happening in their installations or in their substations when they go out to visit the customers. So therefore, it might be hard to find these kinds of typical fault patterns. So this is something that we're working on and trying to find, really. And then also, of course, how much fault diagnosis can we do by just using this billing data? We are not sure if it's possible to be able to find all of the faults. It might be that we need data from the customer side of the substation as well. Just a quick recap here. I'm running out of time, but if we look at the current solutions, the key aspects of successful fault handling processes are close customer relationships, information and clear incentives towards the customers, and also physical access to and mandate of the customer installations. And then also that the most common faults may be very hard to find when only visiting the customer installations. And future solutions, we think that data analysis show great potential to further improve the fault handling processes, and that also fault diagnosis would be needed to identify all of the faults. That was right in time.
Good job. Thank you. Big round of applause. Thank you, Sara. I remember this time.
Oh, thank you very
Thank you so much. Thank you.
Thank you.
All right. So any questions for Sara? That was good. You made it.
Yes. Oh, sorry. I missed this one. Hi there. I was just wondering how long in the future do you think you could do this automatically fault diagnosis if you get the information, how to say, on previous service
Yeah, I see what you mean. I think it's well, it will of course take some time to process the data and to make sure that you have proper diagnosis tools. I'm not sure. I don't want to give you a time span, but I know that more people within the industry are also working on this. So I think we can have some very nice collaboration opportunities there.
Thank you.
It's a very interesting subject, the faults, real faults in central heating installation and substations. To optimize system, I think you should know the actual behavior central heating installation. I mean, the heat demands projected is not equal to the real one. The size of radiators are not suitable to the buildings.
No.
So the mass flow and the supply temperature very change condition of work, central heating installation and substations. As you said, 31% faults are in internal installation. It's because I think you have a good condition of district heating systems. In our systems, 40% is substation.
Yeah.
But to optimize, I think we need to know actual, real characteristics of central heating installation, how it changes with changing temperature, what will be the mass flow and return temperature, and the same for the heat exchangers, not in nominal parameters, but in seasonal parameters, and take consideration in technical state, because they are not new. So in every building, heat exchanger behave in different ways.
Yes, thank you.
So exactly, you should know step by step, building by building, to optimize all the systems. It's a huge work to do, but I think it's a good way to start. You are on a good way.
Yes, thank you.
Thank you. Thank you. All right. And thank you, Sara,
Thank you.
for a nice presentation. Wonderful. So everybody get the number. Can I get